Hello everyone, my name is Pritam Kumar and I'm currently pursuing my BTech first year at Khan Institute of Technology and Sciences. In this video, I'm going to demonstrate my practicum number 9 of Computer Organization and Architecture, which is titled as Stack Operations Using Registers in MATLAB. A stack flows the last in first out principle, meaning the last inserted element is removed first. Let's go with the first program. The first program explains how using a stack helps keep track of values during a program. This clears the previous outputs and variables from the command window. Here we are creating an empty variable called stack, empty array. Here we're pushing 10 into the stack variable. Here we're pushing 20 into the stack variable. In this line, 30 is added to the stack, and now stack becomes 10, 20, 30. And at last it is displayed here on it. It shows us push 10, push 20, push 30, and current stack is 10, 20, 30. The second program is about to know whether the stack or registers are better for saving data. In this code, here we're creating an array with one row and two columns, and we are initializing with zeros, 0, 0. And in the reg 1 equals to 10, it stores the value 10 in the first position, 10, 0, and reg2 equals to 20, it stores value 20 in the second position. Then now the register becomes 10 and 20. The register is full. Here we're creating a empty stack. Then we're adding the values 10, 20, 30 into the stack. Unlike register, no fixed size restriction and can store more elements. Here we're printing the outputs. Here we can see register values limited 10, 20. Stack values are 10, 20, 30. The third program is about push and pop logic to take three numbers and return them in reverse order. Here, after creating the empty stack variable, we are adding values 10, 20, 30 into the stack and we're displaying the label and stack. For the reverse order, the loop runs until stack becomes empty. These empty stack checks if the stack is empty. This still sign means not. So the loop runs while stack has elements. Top equals to stack and gets the last element. This is the top of the stack. First iteration, the top equals to 30, next is top equals to 20, and next is the top equals to 10. So the original order is 10, 20, 30, and the reverse order is 30, 20, and 10. The fourth program is about the predicting what will happen if more data is pushed than the stack can hold. So here we kept the limit as max equals to 3. 3 is the limit. Here the loop runs from 1 to 5, trying to push 5 elements. And this if else statement is about checking the current size of the stack, length of stack, number of elements. If the number of elements is less than 3, it allows to push. Else overflow. Stack equals to stack of I is adds element I to the stack. Push operation. I equals to 1, 2, 3, and so on. And at last we are displaying the values. Let's see. The push 1, 2, 3, stack overflow, stack overflow. So 4 and 5 are not displayed. Final stack is 1, 2, 3. Coming to the fifth program is about to know why the stack follows a last in first out LIFO rule. So we initialize the stack with values as 10, 20, and 30. 10 is the bottom and 30 is the top, and we're displacing the stack output initial stack also 20, 20, 30. Then we are displaying removing elements LIFO. This indicates a pop operation will begin. So this thing, the loop runs until the stack becomes empty. Is empty stack checks if stack is empty. Tilde sign means not. So the loop continues while stack is empty. So let's run this program. Initial stack is 10, 20, 30 and removing elements. Last in, first out. First 30 is popped, next 20 is popped, and 10 is popped next. Coming to the sixth program is knowing about how pop identifies which data to remove first. So here we initialize the stack as 5, 15, 25 values and we display the stack. Next, then top equals to stack n. This line, like stack n, accesses the last element. So this is the top of the stack. Then top equals to 25. Stack is 5, 15, 25. The element to pop is 25. Stack after pop is 5 and 15. Seventh program is about why is it important to balance push and pop operations. So in this, we initialize the stack variable. We push 10 and 20 into the stack. Then at last, we pop the values that removes 20 and then it removes 10. At last, it checks whether the stack is empty or not. If it is empty, it returns true if no elements. It displays message if condition is true, means number of push equals to number of pop. So no extra data is left. So stack is balanced, no leftover data. Coming to the eighth program is about predicting the outcome if a pop is attempted on an empty stack. So we create an empty stack variable, and we using this if statement we check whether the stack is empty. If it is empty, it returns true. If not, it is false. So if it is true, it displays an error called as it displays a message called as stack underflow cannot pop. Coming to ninth program is about how a stack stores return addresses during function calls. So we initialize the stack variable and display the function calls. Then stack we push 100 into the stack, and next we push 200 into the stack. That is function B, and function A is about 100. First line gets last element using the stack n, top equals to 200, returning to 200. Function B ends. Control goes back to the function A. Then next pops gets the new top equals to 100, returning to 100. The function A ends. Control returns to the main program. So let's run. See, simulating function calls. Function A called, return 100. Function B called, return 200. Returning to 200, returning to 100. Coming to the last program, it explains why the stack is often referred to as temporary memory. So here we create a empty stack variable, and we display the temporary data storage, and we push 50, 60, and 70 values into stack. So these values represent temporary data used during execution. This clears the stack completely, removes all the stored variables, and the empty. The data was temporary, not needed after execution. So if you see, and at last it displays the stack cleared after execution. So this practicum successfully demonstrated the working of stack operations using registers in MATLAB. The push and pop operations were implemented to show how data is inserted into and removed from a stack following the last in first out principle. Various conditions such as stack overflow, underflow, and balanced operations were also simulated to understand stack limitations and error handling. The experiment highlighted how stacks are used for temporary data storage, reversing data, and managing function calls through return addresses. It also showed the differences between fixed size registers and dynamic stacks, emphasizing flexibility and practical usage. Overall, this practicum provided a clear understanding of stack behavior and its importance in computer architecture, especially in memory management, recursion, and program execution control. Thank you.